So let's talk about overfitting and underfitting. So now that you have a convoluted neural network, how do you decide on the optimum number of optimum parameter values that you have? Like, say, for example, the number of neurons per layer. Well, the question is it's difficult. You don't really know until you actually try and fill with various number of neurons and other parameters. And there is this good Stack Overflow question, which I will recommend you to look at. And it poses why are we using numbers such as 512 as as the typical number of neurons per layer. And the best answer is, well, it really comes down to you making a simple model and just evaluating its performance and just adding more and more performance and complexity to the model as you go on to get to a more accurate model. And oftentimes you are pushed to create more and more complex models that will produce a higher training accuracy value. But there comes a point when the training accuracy is so high, but at the same time, the validation accuracy is lower than expected. And at that point, you have what we call an overfit. So the training model is overfitting with the spurious patterns inside the training data and not looking for the broad general pattern of the data that you have. So to solve this, we introduce more layers, but not just dense layers that have neurons, more complex layers, more special layers, we call them, that add certain functionality but don't necessarily have any neurons themselves. So one of these layers is what we call a dropout layer, which can help to prevent overfitting. So in the last lesson, we talked about how overfitting is caused by the network learning spurious patterns in the training data. And to recognize these spurious patterns, a network will often rely on very specific combinations of weight, kind of conspiracy of weights. But it is becoming so specific, they tend to be very fragile. Remove one of these weights and the whole conspiracy falls apart. So in order to push this deep learning algorithm to look for more general patterns, we introduce the idea of dropout, basically randomly dropping out any neurons in a particular layer to make it harder for the network to learn these spurious patterns in the training data, and instead looking for more broad and general patterns whose weight patterns tend to be more robust. So here in this GIF, we see a 50% dropout being added to the two hidden layers. So at any one time, 50% of the neurons in this layer is gone from the training batch, and the deep learning algorithm is just forced to learn more general patterns. So you can think of the dropout as a kind of ensemble of networks. The predictions will no longer be made by one big network, but instead of a committee of smaller networks, individuals who tend to make some kind of mistake, but together they form a more powerful entity that will give you the general pattern that you want. So in order for you to add a dropout to your layer, you simply will add a layer.dropout rate is equal to 0.3, meaning a 30% dropout in the next layer. So that is how you add a dropout to a layer. And another layer is batch normalization, which can help correct training that is slow or unstable. So with neural networks, it is generally a good idea to put all of your data on a common scale, perhaps with something like scikit-learn's standard scaler or min-max scaler. And the reason is because when it goes through a certain layer, it can sometimes produce activations of very different sizes, which can make for unstable training behavior. So it is a good thing to normalize the data before it goes into the network and also inside the network itself. In fact, we have a special layer to do this, which we call a batch normalization layer. So a batch normalization layer looks at each layer as it comes in, first normalizing the batch with its own mean and standard deviation and putting it into a new scale with a more normalized scale. And oftentimes this can fix various problems. It can cause training to get stuck. And this is how you add a batch normalization layer. Simply